All right, and we are back solving systems of equations. Now we're going to do it algebraically. We've done it graphing. Now we're going to do it algebraically, and the first way we're going to do it is by substitution. You've heard that word before, so you know what it means. So we're going to substitute. Of course, I have my yellow highlighter, I'm going to have a green highlighter, I'm going to have a pencil, and I'm going to have a black felt tip pen. So let's get started. So in the first example, we have solve for x if y equals 2. Okay, this is our first equation. And then we have our second equation. And it tells us that y equals 2, which is very simplistic. What we're going to do, we're going to substitute the 2 in for the y. And you're going to get 2x plus 3 times 2 equals 24. And then we're going to distribute that. So 2x plus 6 equals 24. And then we're going to subtract 6 from both sides. You get 24 minus 6, is 18. It's equal to 2x. And then we're going to divide by 2. And you get x is equal to 9. Now, when we graphed our systems of equations, the solution was a point. So that's what it's going to be here. We're just doing it a different way. But the point is the x value, which is 9, and the y value, which is 2. So our solution, the answer, what we're looking for, is that point. Okay? The second example says solve for x if y equals 2x minus 2. So there's our first equation. If we were to graph that equation and we were to graph this equation, where would we wind up? Now this one's a little bit different from the first one in that y equaled 2. It just equaled a number. In our second example, y equals 2x minus 2. A little bit larger of a degree of difficulty, but we're going to do the exact same thing. It's just going to add one more step. We're going to substitute the 2x minus 2 there. So you get 3x minus 3 times. Now our y is equal to 2x minus 2. We're just going to put it there. End of parentheses is equal to 21. And now we are going to distribute. So 3x, a negative 3 times 2x would be minus 6x. A negative 3 times a negative 2 would be plus 6 equals 21. Combine like terms, 3x minus 6x would be negative 3x plus 6 equals 21. Subtract 6 from both sides. They cancel there. You get negative 3x is equal to 15. Divide by negative 3. You get x equals negative 5. So right now we know that our x value is negative 5. That's the first point in the coordinates. But we don't know what our y value is. So we have to take our negative 5 and we have to substitute it back into either the top equation or the second equation. The top equation, since it says y equals 2x minus 2, this one's going to be easier to substitute it in. So we go y equals 2 times a negative 5 minus 2. Y equals 2 times a negative 5 is negative 10 minus 2. Y equals negative 12. So now we have an x that has a coordinate and a y that has a coordinate, and we just have to put them together. Negative 5, negative 12. So our solution of these two lines, there where they would intersect, is the point negative 5, comma negative 12. Okay, so that's it. Those are two examples. Now I'm going to give you some steps if you're not really certain how we did it. So the first step says isolate one of the variables. And it could be x or y. In the first example, y was already isolated. It said y equals 2. In the second example, y was isolated again. It says 2x minus 2. Okay? It might say x equals a number. So you can't just say it's always going to be y. Okay? The second thing that we did was we substituted the value of y in that second equation. So we're going to substitute what my x or y equals into the second equation. So over here we said y equals 2x minus 2. We substituted that into our second equation. The third thing we did once we substituted it in was we solved for x. So third thing, solve for the other variable. And then the last thing we did, once we solved for x, we substituted it back into one of the two original equations and then solved for y. So we are going to substitute value from step 3, the step right above, substitute that value back into one of the original equations. It does not matter which equation you use. Okay? Does not matter which equation you use. You will get the same answer. So let's look down here. There are 3 examples. I'm going to do one of them. I'm actually going to do the example in the middle because it looks a little bit different from the other 2. So the example in the middle looks a little bit different than these 2. Okay? And it says y equals negative 4x plus 20 and y equals 2x minus 22. So we know that we have y isolated in both. What we're going to do is we're going to take this one and substitute it for that y. If you wanted to take the 2x minus 22 and substitute it for that y, you could do that as well. But here we go. So negative 4x plus 20 is equal to 2x minus 22. And we're going to solve for x. I'm going to go through this a little bit quickly. Add 4x because I think you should be able to solve for x here. And you get 20 is equal to 6x minus 22. We're going to add 22 to both sides. You get 42 is equal to 6x divided by 6. You get x is equal to 7. So I'm going to highlight that because that is one of my coordinates. Then we're going to take that, we're going to substitute it back in. I'm going to substitute it back into the second equation because I like my x being positive, the coefficient of the x. So y is equal to 2 times 7 minus 22. So y equals 14 minus 22. Y equals negative 8. So the solution for the middle system of equations is 7, negative 8. And that would be your answer. That would be the point where these 2 lines, as they are graphed, intersect. Okay? Finish the other 2 questions and bring them in to check your answers.